Okay, perfect. And yeah, you got my last name correct. People pronounce it both ways, so good work. Yeah, so today I'm going to be talking about searching for the limits of LLM-based systems. It's going to be kind of an exploration. I'm going to go a little bit into theory. Hopefully, it won't be too crazy, and hopefully, we'll get like a good mental model of at least how I approach this, right? So, why is this important, right? We as practitioners and decision makers, it's important for us to have like a semi-decent mental model of what we're working with, right? Even if we're not like necessarily have a PhD in this stuff, we should understand what the technology is in order to make better decisions, whether or not like it makes sense for our business, for our customers, for our bottom line, right? Um, so together, I want to first take a look at a little bit of the theory. We'll go very, very quickly, very high level, and go into a few things that might not come to mind when you think about LLMs, but I think is relevant. And then we'll talk a little bit more practically where we could see high use cases of LLMs and where we think it won't work as well. So what is an LLM? Before we even go into that, we should talk about what is the whole notion? What are we trying to accomplish, right? What are deep learning engineers or ML engineers trying to do when they're training these models? Essentially, we have this toolbox called mathematics, right? This toolbox has existed for a long time, and we came up with a lot of ways to talk about relationships in mathematics, a lot of vector spaces and distances and similarity metrics. We have all these tools, and we want to apply it to a system that we use as humans, which is communication, speaking, right? I speak with you, you speak with me. We understand what that means. But as in the computer age, how do we take that understanding that we have of human communication and language, and how do we put that into a way that can be computed by our computer, right? Computers think in numbers. So how can we take that and put it into a computer? And this has been, an open conversation in machine learning for a very long time. Large language model is a new approach to it. We've had bag of words, different types of ML models like Word2Vec and BERT. There's been a lot of ways to talk about it. LLMs have just been the most recent and obviously the most successful. So what is an LLM, right? An LLM, again, as we said, we're trying to take something and make it mathematical, right? So what an LLM does is, this is might look scary, but basically what this means is a probability distribution over language, right? We are training a model to learn a probability distribution over language. What that means is basically, given this sentence, given this word, given this paragraph, how probable is this paragraph? Does this make sense, right? And even further, what would be the most probable next word in that sentence, right? So basically, that's a way to take this task of like, how can computers understand language? And we're trying to make it into something mathematical. So that's what we do for an LM. We're trying to train a probability distribution. Now, what made this wave of NLP, specifically with the LLM, super successful is this attention mechanism. So you may have heard of attention. It's what also basically all these LLMs are based off of. It gets pretty, we have this nice graphic here, not super relevant, but it just allows you to, this has been super successful way to learn the probability distribution that we said before, right? So like empirically, in theory, we've always wanted to learn a probability distribution. We just haven't had the tools to do it, right? Because it's very difficult. There's like a ton of probabilities and stuff like that to calculate. So this attention mechanism made it possible, made it easy for a computer to learn at least an estimation of this probability distribution. Now, the next, this slide, basically probability distributed language, like what's going to come next, right? How probable is this, piece of text or whatever, right? That's basically what an LLM is. Now we're going to get into a little bit of like, a little bit more theory, but what I find pretty interesting. So what are the limitations of algorithmic learning, right? So one, we have two pictures here. We have Kurt Gödel, he's from the early 20th century. We have Roger Penrose, who I believe he's still alive, right? He just won the Nobel Prize. And Kurt Gödel, one of his contributions to the field of mathematics was something called Gödel's incompleteness theorem. And basically, it was a crazy realization where he proved that there are statements in mathematics that mathematics itself cannot prove. So what he showed is that there's an inherent limitation to any system of mathematics, right? So what that means is like we come in and we're like, mathematics is ultimate. It could do everything in this world. And he's like, no, it can't. And he proved by coming up with a statement that there's no way to answer it within mathematics. Roger Penrose most recently wrote 2 books. I mean, he's a physicist, but he's also very into consciousness. And he wrote 2 books. One of them is called The Emperor's New Mind. The other one is Shadows of the Mind, where he basically argued that the biological processes that go in place in our brains for consciousness and the way we think are non-algorithmic. And he tries to prove, using Gödel's incompleteness theorem, that any algorithm that can be written cannot imitate consciousness. So what am I bringing this here is, for example, according to Roger Penrose, like Kurt Gödel's theorem is proven. That's known. Like no mathematician goes against it. Roger Penrose's application of Kurt Gödel's theorem is not proven, right? It's just his book, and he puts a very strong argument in my opinion. But at least this goes to show you that there are limitations for any deep learning algorithm, at least according to Penrose, right? There are a lot of people who disagree with him. You can look it up, but that's at least just to frame us. We cannot promise the world in deep learning and machine learning. It's very important for you to understand that even the science understands that, right? That you cannot promise the world. Now, another limitation thing I want to talk about is, there's always people that come to us at PumpLayer and they're like, oh, you guys are in prompt engineering. What's going to happen when they get rid of the prompt engineer, right? Oh, they're just going to, the model's going to know exactly what you want. So I'm not entirely sure what that claim means, right? But basically what Claude Shannon he had this contribution into entropy about information theory. He said there's a limitation in a communication channel with the amount of information you could represent. In other words, he said, if I am talking to you and I want to basically tell you something like, please get me a cup of water or something like that, there is a limitation with how efficient I can get with how to communicate that with you. But I cannot go beyond that. In other words, the reason why I'm bringing that here, and let's go into this last page here on theory, is that at the end of the day, there are limitations of communication. So the model, for example, in prompt engineering and LLM space, there are certain things that you will have to tell it. It cannot guess or learn or create information that doesn't exist. Like, how does it know if you're trying to get a flight to Kansas that you want to go through New York if you didn't tell it, right? Like these types of limitations are inherent. These are black and white pictures inherent in this system of statistics and mathematics and probability, which a lot of people, especially the people on Twitter, forget, right? We are limited by our capabilities, and a lot of these limitations have been proven. Okay, so that's a little bit of theory. Now let's go back to LLMs. What does this mean, right? So both the limitations part and also the probabilistic model over language, right? So I think if we go back to the first thing I was talking about, the probabilistic model over language, right? What we could talk about is like, what is it most definitely good at, right? Most definitely, if it's a probability over language, as in it's taught to predict the next word, right? What can it be good at, right? So very simple, highly textual based tasks. This is what it was basically trained to do. Summary, question answering, recall, right? Structured input output. Think of coding. Like, for example, coding is a perfect example because like if it's probabilistic model over language, including programming languages, which are highly structured languages, it knows that if there's an opening squiggly bracket, high probability within the next few lines, there's going to be a closing squiggly bracket. It knows that because that's a very simple probabilistic problem, right? So it's going to be very good at that type of task. So basically, these are the things on the left are like autocomplete type tasks. Very, very good at that. That's exactly what it was trained at. Question answering and recall, also pretty good at, because if you think about it, like when you have like bodies of text and stuff like that, people, especially over the internet, tend to summarize, tend to do those types of things. So it could learn that easily. Things that it will most definitely have difficulty doing is math, right? Like, yeah, especially when ChatGPT came out, a lot of people were giving it math problems. Oh, it could do this and it could do that, right? But the thing is like it's a probability distribution. It's not trained to do math, right? So even if it could answer some of those mathematical questions, it's trained to talk about what's next in the thing, not to do math, right? That's like a completely different mechanism, right? That, by the way, is like solved for computers to do math. So for example, on that topic, ranking, sorting, long-term memory has nothing to do with the mathematics itself. It's just a limitation of silicon. And there are ways to go around doing that and stuff like that, but we're going to be limited by the amount of like context window based on like how many bytes a word takes and stuff like that. Like that is a mathematical discussion as well that you could talk about. high precision tasks in general, right? Like where you're asking it to basically do like something like math or that type, which is like symbolic in nature. Like that's not really what it was trained to do. Can it do it? So let's go on to this next slide here. Can it do these stuff that I put into the right column? Yeah, probably. Probably could do some of it because it's a probabilistic distribution over language. So it's probably seen it in some of its training data, some of these mathematical things, and just learn that statistical representation. But in terms of like really understanding it or taking stuff that are out of distribution, when we talk about out of distribution, is like things that it never saw in its training data, probably will not succeed at that so well, right? And also, it would be kind of futile for you to give it a bunch of training data to teach it to do math, right? Like that's just a misuse of technology here. Like, why are you trying to get an LLM to use math? Now, that's like the limitations of LLMs and that type of stuff based on just a casual conversation with what at least what I see and we see at PumpLayer and what we think based on the theory, right? Now, in practice, there are multiple, and I forgot to add just like the standard approach. There are multiple different ways to use an LLM. One is the standard approach, which is just you ask all the questions to the LLM and that's it, and you get your response. And that could work with certain highly textual, like summarization, those types of things. It's just few shot learning or things like that. Then we go on to this hybrid approach, which you could think of ChatGPT plugins. You could think of like functions. I don't know how many of you guys have heard about the OpenAI functions, which allow you to use ask the LLM to use a tool in its toolbox. What this is doing is using the skills of LLMs as a brain to be able to complete sentences, right? Which is like, for example, question answering that we spoke about is a task that LLMs are good at, right? So you could ask the LLM, what tool should I use? Should I use a calculator or a banana to calculate, mathematical question? LLM is very good at telling you to use a calculator, right? But it's not very good at doing the actual calculation. So this is a hybrid approach where you use the LLM as the brain, right? And you have a toolbox, right? So this is a way of leveraging all the technologies that we have, right? Another type of approach is a copilot approach, right? There soon enough, I mean, it's already cheap, but soon enough, these LLMs will be even cheaper. And then like you could just ask it to do like 10 or 15 iterations of a question and then let a human just pick whichever one's better. And this could like kind of allow the human to be like, 2x, 3x, 10x more efficient at their job, which could, obviously change the bottom line of a company. So now let's talk about use cases. We're going to start with like internal use cases. For example, this was like a big tweet that got a lot of action last week or another week ago, where exactly as we're talking about, these copilot use cases are small stakes, low stakes, right? You just do it internally. It's a copilot, so it's not even external to customers. It's not making business decisions. You're just opening this up for all of your employees to use, right? And like, it could write you emails. It could help you, do like social media posts and stuff like that. So now, or like help you do PR reviews and code and things like that. So like we're seeing already two founders. This is Patrick Collison of Stripe and Mike Noop. I don't know how to pronounce his last name, but from Zapier. And they're both talking about how internally, this is 1/3 of people, this is 50% of people at their company are using LLMs for internal use cases. I don't know how much use they're getting if like they're replacing their work, but definitely enough that like it's at a company of these two sizes, it's causing a lot more efficiencies, which at that scale is amazing. Imagine the amount of money and time they're saving using LLMs. And this is extremely low stakes, right? They basically, from what I understand, these companies like have like a ChatGPT with a bunch of saved prompts that the community at this company, they could just share it. Like the salespeople could be like, oh, this is a great prompt. And like these people could be like, oh, this is a great prompt. And they just share it amongst each other. Very, very low stakes use case. And already has been proven, right? We're talking about the hype of AI and this and that, proven that it has been beneficial for these companies, right? Now we have more external facing ones. And this Loom is my favorite example of an extremely, extremely low stakes, but it's not Copilot, it's external facing, and it's not even hybrid use of LLMs. So if you upload a video on Loom, they've had like a transcribe feature for a while. Now they have a way to basically using an LLM, take that transcribed thing, transcribed script of your video and make a title for it. So here, I don't know if you guys can see my mouse, but this like understanding, get request, and pagination is something I sent to some engineer, right? And this thing, very low stakes, but it doesn't really matter, right? It doesn't really matter if it gets it wrong. First of all, as we were talking about, the LLM is trained on summarization. That type of stuff does really well. So this is basically a summarization task. If it, was slightly off, who really cares? Low stakes. Again, low stakes, easy, simple, amazing, right? Let's go to another one. So Speak is actually a customer prompt layer. This is not as much low stakes. Basically, they have a chat app that you could learn how to speak new languages, and it's powered by LLMs. But again, it's a use case where an LLM is pretty good at, right? Like generating text, continuing conversations, and stuff like that. And so this is not low stakes, right? It is customer facing, not a copilot, but they have been able to leverage something an LLM is good at, right? Text generation, and build a beautiful product out of that. Another company here, this is Appsumo, another customer of PromptPlayer. They have this Ask Sumo functionality, which is like an alternative search on their website. It's like almost a chatbot where you could ask it, like Appsumo, by the way, if you guys don't know, it's like an e-commerce website or a website to find SaaS products, right? So you could go in and say like, hey, I'm looking for software to help me edit photos on an iPhone, right? And they created an Ask Sumo service, and this is hybrid is a hybrid approach because they use a ranking system, but they basically take the question into the LLM, figure out a way to then query their set of products, and then they come out and give you suggestions. So this one is not so low stakes, right? And this one, this is a little bit more difficult to do, I would say, than the other ones, right? To do it right. But it's not so low stakes, and if you have a mistaken answer, it's a little bit more difficult. That's what I'm saying. Like, if you give it a product that's not relevant, customer experience is kind of annoying, right? Like, why did you recommend me an Android app? I said iPhone, right? But so there's a little bit more subtlety involved in here, but they're basically using an LLM in order to query that. Another example we'll go to is Notion. Again, very obvious, extremely obvious. And I guess the summary is we're seeing a lot of obvious use cases being the most successful ones now, which makes sense, right? We're going to see the obvious ones because they're obvious, and we need the time for the more complicated ones to develop. Notion AI, if any of you have used it, has like a bunch of functionality with generating text, rewriting text, changing the tone, summarizing text, all these things, as we said, very, very, first of all, it's kind of a copilot, right? Because the person could accept or reject the responses. And second of all, it's something that an LLM in theory is very good at, right? So they're just leveraging that. Quite simple and a quite good use case. Okay, so now, going to conclude now, looking into the future, what's going to happen? I don't know, to be honest. I mean, I think one thing that we've seen, and I've tried to show in this presentation, is first, there are some limitations. And I think it's important to be honest about that, right? That there are limitations, especially as people who are going to be advocating for these products and tools to be used in the long term. If you come in and promise that it's going to solve everything, it's just a waste of time. It's just a hype cycle that's not going to last, right? So the hype has slowed down a bit, definitely, but we've also seen with the examples of that we just demonstrated, we went through a bunch of examples, both internal and external use cases, that there has been proven business value, right? Companies are saving money or making more money using LLMs. So LLMs are here to stay, obviously, in our opinion, right? And they're here to stay and in a business impactful way, absolutely. How is it going to stay? I think a lot of hybrid approaches is very good. I mean, OpenAI is also doubling down on that with their OpenAI functions that they allowed. Copilot, very easy. Most obvious way to go about doing things is Copilot. We'll see in the future where you have these autonomous agents, whether or not that will take place, where they like make decisions and no Copilot involved. That could possibly happen. That's a little bit more higher risk, right? We'll see if that works. I think there are a lot of use cases where that will work really well, and a lot of use cases where they'll probably have a human in the loop for the foreseeable future. Okay, so now I'm going to conclude. Basically, talk a little bit about PumpLayer. Just a little shameless plug. We are an LLM observability platform that's focused on allowing teams to collaborate with LLM products in production. So we have a system that lives alongside whatever API you use, and also a front end for like a PM or other technical and non-technical members of your platform to come in and help you iterate with prompts. We have a prompt registry. It's like a visual way to iterate prompts, push into production without having to be a software engineer, which is part of our thesis, is that this is going to be a collaborative experience in the future. We also have evaluations and analytics and ways to iterate and validate that the changes you're making in your prompts are going to be not going to cause any customer harm once you push them to production. Okay. And then last slide here is, check us out our website, sign up. We have like a generous free tier. Follow us on Twitter and LinkedIn. If you have any questions, it's my email. Also, we're hiring a founding engineer here in New York City. If any of you guys are connected with anybody, software engineering, that would like to work at a startup doing cool things, definitely send them our way. And that's it for me.
All right. First off, Jonathan, thank you so much. And I, as a fellow geek, like in the group, I feel like I'm safe to say everybody's a little bit of a geeky nerd here. We're all spending our Monday at an AI conference. I'll out myself. I'm a geek. I loved like the mathematical and the theoretical introduction to your talk. I think that provides a lot of beautiful context behind the whole world of LLMs and where we're going here. And love to hear your hiring. And if you haven't taken a stab at an early stage startup, I definitely do recommend. I think I made some huge growth when I was in that phase. But we've got a lot of we've got time here for questions. If anybody has any questions, I'm seeing a lot of great job, Jonathan. So a lot of it. Matt Dupree does have a question. Which book by Primrose would you recommend?
Shadows of the Mind.
Shadows of the Mind.
Yeah, the Emperor's, I think it's called The Emperor's New Mind. That one is older. Shadows of Mind basically copies the same arguments and just expands a little bit more, and he has like extra things. But he goes really deep into the physics, so you could skip that part unless you're really interested. But at the beginning is where he makes his majority of his argument. Yeah,
I'm personally now I'm like also getting book recommendations from all of this, so super great. Yeah, if there's any questions, feel free to drop them in the chat. I'll be here looking for all of the questions. But I love kind of one of the things that I really touched on was how you talked about how these different LLMs can be placed within other applications and other workshops. So we went over very briefly. Rizal added the Loom AI feature. We saw the Notion AI feature within your talk today. Is there further AI implementations that you're seeing that you're really interested in or curious to play around with?
Yeah, I think like, for example, we focus heavily on our customer use cases, right? Like we try to target customers that are doing like very interesting things and try to develop for them. So like Speak, for example, is a customer that we're extremely excited about, right? They're like using it heavily to come up with like customized content for people who are trying to learn languages. So that is very good, and it's very exciting to see. I think a lot of the like low hanging fruit, easy ones, like for example, Superhuman just released Superhuman AI about a month ago. Also useful, extremely exciting to see. What I'm excited more is like, for example, I was just like recently booking a flight or like looking for like hotel recommendations and stuff like that. I know there is plugins for like Expedia and those type of, I don't remember which one on Chat GPT, but like those types of like older websites adding like a more conversational LLM approached way of like, hey, find me a ticket from this location to that location, or help me summarize that, or give me a report of like where I should visit. Those like it's gonna happen, and I'm sure there's a ton of like side projects and small startups that are doing that. But I'm excited to see once Expedia or like those bigger companies produce that, because they have all that data and stuff like that.
Yeah, personally, I know I'm about to book my fall conference travel, and that's already something that's on my mind is like, oh crap, really not ready to do that, because I feel like there's always the 10 different apps out there that you can all choose, because and Brian just tossed this in the chat. Using AI for travel planning would be a huge help because it is a mess. Yeah, total mess. I think I paid more. I always tell people the biggest shocker I had was I paid more to fly from New York to Salt Lake City for PyCon this year than I did paying to go from New York to Berlin. And that was a direct flight to Berlin. So I was like, wild there. But thank you so much for your time. It looks like, and I think as I say that, we've got one more question, popping up in the chat. All right, one question coming up from Jimmy Reichley. It seems like full AGI is actually unattainable based on the introduction of this talk. Is that your perspective as well?
That is my perspective. That's my opinion. And Roger Penrose argues very heavily about that. However, a lot of like the OpenAI, like I'm just a small random, like, you know what I mean? Like, you know, Sam Altman and those people of the world and Elon Musk's of the world, they believe in AGI very heavily. But I haven't seen a good response to like Penrose's argument. There's also another thing, like even people who do believe in AGI, for example, Jan LeCun and those types of people, they make the argument that the LLM is not it. So like even if they do believe in this artificial general intelligence, there are those people who don't believe the LLM is the framework to bring us to that AGI.
Oh, I'd have to like agree with that. Like, I don't know if it's having worked in it myself. I don't know that an LLM would be the first framework to kind of make that happen. If it is, I mean, I kind of lean more
Yeah.
on the skepticism side of things. I mean, in my brain, it's like, this is a giant math equation.
Yeah, I mean, in my personal opinion, and I don't know, this could just be wrong, is like we're not philosophers here, right? I mean, we could talk about philosophy over beer or something like that. We're business practitioners trying to provide value to our customers, right? So let's just focus on that, right? Like, why is AGI kind of relevant? It's not really, like, it's just fun conversation to have over Twitter, but for like a company like, you know, Loom, not relevant if AGI is not possible. It's like, what can we use this tool for? And I think that's what we should be focusing on, you know, in a conference like this one, right? As opposed to a conversation about AGI.
Are you saying that we should be focusing on practical application of these tools and not the science fiction options?
After hours, we could talk about science fiction.
I was going to say, well, our comedy group might have another conversation there, or comedy later today. One last question here. Matt, and I've got my own take on this question, but I'm curious to hear yours, Jonathan. What is the most interesting use case that you've seen for LLMs?
Most interesting use case I've seen for LLMs, you know, honestly, all the ones I spoke about are pretty vanilla, to be honest. But I have seen some people try to, like, you know, go through a bunch of like documentation or like, you know, whatever to come up with arbitrage opportunities. That's pretty interesting. Or like basically use it a way to like come up with like thousands of, you know, different, you know, like logos or something like that, right? Where it's like basically using the idea that it could come up with like concepts and ideas. Most of them are probably garbage, but scaling that out to a huge scale, right? And like seeing that, right? So like, for example, just talking to a company that like trying to do like pharmaceutical research, right? Again, as I said in my talk, like that's not something that LLM is trained on. But because it has probably distribution over language, it can pick up a bunch of bogus ideas, and some of them could be good, right? So you as a human who have this knowledge could just like read through them and like use it as a way to like surpass your writer's block, right? Which I think is kind of interesting, like a fun little, you know, way to go about doing that as a tool.
Yeah, no, I think that's a really great approach. One of my favorite talks at PyCon this last year was using, and they fine-tuned the stable diffusion model to make a Pokemon generator, and that was built by Rob DeWitt. And I still think like these fun large model applications are super fascinating.